Okay, so today we are going to talk about how we can use point slope form equation to help us solve word problems, or in other words, applications. And so we'll go through a quick review of point slope form and what it looks like and how we use it, and then we'll do some actual word problems together. So, quick review. Point slope form looks like the equation that you see on your screen. And it's called point slope form because quite literally we have a point and a slope that we can get from that equation. And our slope is always, we always use the letter M to represent the slope. And our point is always written as a coordinate like X comma Y. And we'll say that this point, X comma Y, comes from point 1. So we use like X1 comma Y1. And in the formula, we plug the slope in there in blue, that M, and then the values from the point X1, Y1 go here in green. And then the important part for you to remember is that the black X and the black Y in the equation are literally the variables, the letters X and Y. So the Y1, the M, and the X1 are all numbers. Okay, let's get into it. So, couple quick practice problems. If I have 2 points and I want to write the equation in point slope form, remember that looks like Y minus Y1 equals M times X minus X1. And then they're asking us to convert that equation to slope-intercept form. In other words, solve for Y. Okay, so step 1, anytime I write an equation, I need the slope. So I'll call this like X1, Y1, X2, Y2. And actually, I'll write my slope formula up here for you. Hopefully, this should look familiar. To find the slope between 2 points. So 3 minus 0 over negative 2 minus 9. And so 3 minus 0 is 3. Negative 2 minus 9 is negative 11. That can't really be simplified. I'm going to use this point here because I like that it has a 0, to be honest. So I'm going to plug in Y minus 0 equals negative 3 over 11, X minus 9. Now, I can leave my equation like this, or really in point slope form, I should simplify. Y minus 0, I don't need to write. So it's just Y equals negative 3 over 11, X minus 9. So this is kind of a good rule of thumb. Whenever you see, if it's in point slope form, but like, you're like, wait, what am I subtracting? Y minus what? Well, that what is a 0. Okay, last but not least for this problem, we're converting it to Y equals mx plus b. So in this case, Y is already by itself, but I do just have to get rid of the parentheses by distributing and multiplying. So I'm going to multiply the negative 3 over 11 times X. And then I'm multiplying negative 3 over 11 times negative 9. And a negative times a negative is a positive. And 9, remember, is like really 9 over 1. So 3 times 9 is 27. 11 times 1 is 11. So there's my equation in slope-intercept form. All right, let's try another one. Same thing. Call this like X1, Y1, X2, Y2. We're going to find the slope first. 2 minus negative 1 all over 2 minus 4. Minus a negative becomes a positive, and this is a negative 2. So my slope is negative 3 over 2. And I can use either point. It doesn't matter. I'll use this one this time. So when I plug in Y minus Y1 equals M times X minus X1. That is my equation in point slope form. I could have used the other point for both in number 1 and number 2. If I'd used the other point, my equation would look slightly different, but it's still completely correct. Now converting it to slope-intercept form, I got to get rid of the parentheses. So I'm multiplying. A negative times a negative is a positive. Use your calculator to multiply that fraction times the negative 3 over 2 times the 2. And then I'm going to add 2. And so my final answer in point slope form is that. Okay, so now that we reviewed that, let's actually talk about linear relationships. If you remember, in order for pattern or data to be linear, you have to find a pattern, and specifically the pattern has to follow like an addition or subtraction pattern. If it's multiplication or division, it's exponential, and if it's something other than multiplication or division or addition or subtraction, it's neither. It could be not exponential and not linear. So let me look at the x's here. From negative 3, and I'm on number 3 here. From negative 3 to negative 1, I'm adding 2. From negative 1 to 1, I'm adding 2. And from here to here, I'm adding 2 as well, right? So that's good. I'm really focused. The pattern in the x's should always be adding or subtracting the same number every time. I'm really focused on the y's. From negative 5 to positive 1, that's actually increasing by 4. And if I add 4 again, I'm at 3. And then if I add 4 again, I'm at 4. So this tells me, yes, it's linear. Oh, yes, it's linear. So now I need the equation of the line. So keep in mind what a table is. A table is just a whole bunch of points. You have a list of x's and a list of y's. So put them together, that gives me the point negative 3, comma negative 5. This right here, this gives me the point negative 1, comma negative 1. And then I could keep going and going. But like this is the point 1, comma 3. And you don't have to list these all out. I'm just making sure we're all on the same page. Last but not least, you have the point 3, comma 7. So you really have 4 points here. And in order to write an equation, you just need 2 points. So pick 2 points. I'm just going to pick this blue one, and I'll pick the one above it, the green one. It doesn't really matter, whichever ones you want to use. But so remember, we have to find the slope of the line. So I'm going to actually, hold on. I'm going to say, yes, it's linear. I'm running out of room here. So I'm going to find the slope of the line. So I'll call this x1, y1, and x2, y2. So 7 minus 3 over 3 minus 1. So 4 over 2, right? Which is 2. And then, again, pick any of the points. Any of those 4 points, doesn't matter. I'll just pick the one in green. Y minus 3 equals 2 times x minus 1. So that's my equation in point slope form. And now listen, it just says write an equation of a line. It doesn't tell me what form. So if it just says an equation of a line, it can be any form. If it did specify that it has to be slope-intercept form, y equals mx plus b, I could take this one step further and distribute and then add that 3, and I would get y equals 2x plus 1. But again, this is kind of unnecessary because it doesn't ask me to do that. All right, let's look at number 4. So I took up a lot of room on number 3 there. So let me go like this. Hold on. All right, number 4. Let's switch color. Should we use blue? Let's do it. Okay. So let me look at the x's. I got to make sure the x's are going up by a constant. Oh, I wrote 2. I'm sorry. I got to make sure that the x values are going up by a constant rate, which they are. If I add 1 every time I get to the next one, right? Now, how about those y's? -5 to -6, they're actually decreasing. But how much are they decreasing by? Looks like they're decreasing by 1 every time, right? So, yep, it's linear. Okay. So pick 2 points. I'm just going to highlight my 2 points. Let me get a nice yellow here. So I'll use this point and I'll use the one right below it. Keeping in mind, it's the point 1 comma negative 5 and 2 comma negative 6, right? Like x comma y. So my slope is y2 minus y1, negative 6 comma negative 5 over x2 minus x1. So this becomes a positive. Negative 6 plus 5 is negative 1. 2 minus 1 is just 1. So this actually simplifies to negative 1. And then I'm going to pick any point. I'll just pick that first one to plug in. Y minus negative 5 equals negative 1 times x minus 1. Got to simplify this. This turns into y plus 5 equals, and I actually don't need that 1, right? This just could be a negative x minus 1. You could put the negative 1 in front of the parentheses too, but there we go. That's number 4. I'm taking up a lot of room here. Okay, so pick another color. Let's use green. All right, number 5 and number 6. Why don't you pause the video, try these now, and then when you unpause, we'll quickly go through it together to make sure you got the right answer. Go to it. Okay, let's check in. So in this case, the x's are actually decreasing, right? But that's okay as long as it's decreasing like by the same amount every time. And the y's are decreasing by 1 as well, aren't they? So this is, yes, it's linear. So pick 2 points. This time I'll use the 2 in the middle. Again, it doesn't matter which 2 I use. But here's what does matter. This is the point, negative 8 comma negative 5 and negative 10 comma negative 6, x comma y. So m equals negative 6 minus negative 5 all over negative 10 minus negative 8. These minus and negatives both become positives. And so this is negative 1 over negative 2, which reduces to positive a half, right? And then depending on what point you picked, depends on your equation. I'm just going to pick this first point. So y minus negative 4 would have become y plus 4 equals 1/2. X minus negative 6 would have become x plus 6. So if you had picked one of the other equations, one of the other points, like the second point, your equation would have been y plus 5 equals 1/2 times x minus plus 8. If you pick the third one, y plus 6 equals 1/2 times x plus 10. And if you pick the last one, y plus 7 equals 1/2 times x plus 12. So any of those is fine. All right, and we got to keep mixing it up. Let's use orange here. Okay, let's look at this pattern. In the x's, I'm adding 2. Adding 2, adding 2. Here, I'm subtracting 6. 2 minus 6 is negative 4, and negative 4 minus 6 is negative 10. So this is linear. So the slope, pick 2 points. I'll just pick those first ones. Let me highlight them again for you, this and this. So 2 minus 8 over negative 1 minus negative 3, which is negative 6 over, this becomes a positive, 2, which is negative 3. And if I use that first point, my equations, y minus 8 equals negative 3 times x minus negative 3. Minus the negative becomes a positive. And again, if you had picked a different point, you would have still gotten the same slope. It doesn't matter which 2 points you pick, your slope is going to be the same, but your equation might look different. Okay, so that was our good review of point slope form, and also talking about whether relationships are linear or not. Now let's talk about independent versus dependent variables. So the independent variable is always the x value, while the dependent variable is always the y. So think about what affects the other. The independent variable affects the dependent variable. The independent is what you can control, the dependent you can't control. And let's look at some examples. So your grade in math versus your test scores, meaning like your grade on your report card, like your overall grade. So does your grade on your report card affect your test scores? Or is it that your test scores affect your final overall grade? So it's your test scores affecting your grade. So X would be your test scores, Y would be your grade. How about age versus height? Does you aging cause you to grow, or does you growing cause you to age? And I talk a lot about whenever you have measurements of time, that's typically your independent variable because you can't control time, right? In this case, you can't control your age. Your age is impacting how tall you are. So again, last one, your grade on a test versus the hours you spend studying. Which impacts the other? Does your grade impact how much you spent studying for that test? Could that even make sense? You get your grade after you study, right? So the hours you spent studying impact your grade. So this is super important, keeping in mind what's your independent variable and your dependent when we get to these word problems, and you'll see why. So here's an example of a word problem. 1 week, Jared is earning $20 for 2 hours of work, and the next week he's earning $55 for 5.5 hours of work. So step one, you're going to identify variables in this situation. The root word in the word variable is vary. A variable varies or changes, right? So, or could change. What are the things that are changing in the situation? Well, 1 week he's earning $20. Does he have to earn $20 every week that he works? No. So the amount of money that he's working is a variable, but also it looks like the number of hours he's working is a variable too, right? So my two variables are the number of hours of work and the total the total amount of money he makes in that week. So let's think about independent versus dependent. Which one affects the other? Keeping in mind, most of the time when you have measurements of time, you can't control the measurements of time. So that's your independent variable, right? So the number of hours of work impacts his paycheck, right? So X is the number of hours and Y is how much he makes. So part B, it says write 2 points using the variables you defined. So I'm going to go through and I'm going to say, let me highlight these in different colors. And you're about to see why. Because when I reread this, 1 week Jared earns $20. Oh, okay. So there's a total amount of money that he works for 2 hours of work. Okay. So there's a number of hours. But then the next week, he's earning $55 for 5.5 hours of work, right? So it's kind of like they're giving me a whole bunch of information, a couple different number of hours and a couple different amounts of money that he makes, but they go together because in 1 week when he earned $20, it's because he worked for 2 hours. So these go together and you're going to write them as a point, X comma Y. But the important part is the x always has to come first. And we identified that the independent variable is the number of hours of work. So 2 comes first, and then the total amount of money he makes is the dependent or the y variable. So I'm going to take that information and write it as a point. Same thing over here. When he worked 5.5 hours, he made $55, right? Okay, so there's my 2 points. That is really the hard part. The rest of this should be pretty easy. Use those 2 points to write an equation, just like we've been doing. We need to find the slope first, and then we're going to pick a point and plug it in to point slope form. So slope first. M equals, I'll call this x1, y1, x2, y2, and I could have reversed the 1s and the 2s, right? But 55 minus 20 over 5.5 minus 2. So use your calculator. 55 minus 20, 5.5 minus 2. Now here's a big rule. In math, you are never allowed to have a decimal within a fraction. That's a big no-no. So right now, use your calculator. Divide 35 divided by 3.5. And you're going to see that slope is 10. Okay? So now, I'm going to pick either point. I'm just going to pick this one. And I'm going to plug in to write the equation. Y minus 20 equals 10 times x minus 2, right? So I plugged into y minus y1 equals m times x minus x1. There's my equation. If you're asked for the equation in y equals mx plus b, what could we do? We could distribute the 10, and we would have y minus 20 equals 10x minus 20, and then add the 20 to both sides to get rid of it there. And actually, negative 20 plus 20 is 0 again, and I don't want to write a 0. So if I needed this equation in slope-intercept form, it's y equals 10x. Okay, so the important part is making sure you're defining your variables correctly, because as you can see, if you don't define your variables correctly, the rest is all going to be wrong. All right, here we go. Angela has an ant farm. She buys 30 ants to put in the farm, and then after 2 weeks, she has 35 ants. So what is varying? What is changing in this situation? Certainly the number of ants is changing, right? Because at one point, she has 30 ants, and then at one point, she has 35 ants, right? But what else is changing? The other information they give me is that like after 2 weeks, so the number of weeks is going to be another variable. Which one affects the other? The number of weeks is affecting how many ants you have, because how many ants you have can't impact the number of weeks that have gone by, right? That doesn't make sense. So this is X, this is Y. And I'll highlight this pink. So 2 weeks, she has 35 ants, but I don't have another number of weeks. So let me go back and reread this. It says she buys 30 ants to put on the farm. So that's kind of like at the start. It's like she starts with 35 ants, right? So how many weeks have gone by at the start of the ant farm here? Well, think about like, have you ever run a race? Have you ever done a timed mile in gym class? If you've if you've ran a timed mile, you know, your gym teacher has you line up at the start line, and when they say go, they click the timer, and how much time is on the timer? 0 minutes, right? When you're born, how old are you? The second you're born, you're 0 years old, right? You don't turn 1 until a year later. So at the start, we're going to say that that's like 0 weeks. Okay, so there's our second amount of weeks. So again, take this information, write it as 2 points. So 0, 30, she started with 30 ants, and after 2 weeks, she had 35 ants. How did I know which one went first, the 0 or the 30? It's about how I define my variables. I decided that number of weeks is independent, so we call it X, and X comes first in the point, right? Number of ants is dependent, and that's the Y, and that comes second in the point. Okay, so now I need the equation. Always find my slope. So 35 minus 30. You should hopefully be good at this by now. Oh my gosh, I wrote 35, sorry. So 35 minus 30 over 2 minus 0, which is 5 over 2, right? Pick a point. I'll pick this one because I love zeros. Y minus 30 equals 5 over 2, x minus 0. Now, if I have x minus 0, do I need the minus 0? No, to simplify that, I should just make this 5 over 2x. There it is in point slope form. And if I wanted to, this is a very easy one to convert to y equals mx plus b, because I don't have to do much to distribute. And then all I have to do is add the 30 to both sides. So if I wanted it in y equals mx plus b, it would be this. Okay. Now, if they asked me to make a prediction, so if we keep up the same rate, how many ants would there be after 4 weeks? Think about what you would do. If I had to figure out how many ants there would be after 4 weeks, well, the number of weeks, right, is pink. Excuse me, sorry, hold on. The number of weeks is pink, right? So if they say how many ants after 4 weeks, I would take a 4 and plug it into x there. Okay, so we did some good example problems together. Next step is I am going to have you do some of your own practice problems. So ready? I'm going to put a problem up here. You're going to take a minute and read this, and you're going to follow this process. You're going to pause the video, follow this process, work through the problem, and then when you unpause it, we'll go over it together. So keeping in mind, the variables are the things that change. What in this situation is changing? And then think about, once you've identified those two things, which one impacts the other? The independent variable is x, dependent is y. All right, I'll stop talking, you pause, and then when you unpause, we'll go through it. Okay, 2 variables, ready? I notice that he's downloading a certain number of songs and he's paying a bill, right? Those are my 2 variables. And which one impacts the other? The number of songs that he's downloading is impacting how much he's paying, right? So then I go back and I have to write 2 points, keeping in mind x comma y. So it's like songs downloaded, comma, cost of bill. So 1 month he's downloading 12 songs and gets the bill for $35.88, right? And then another month he's in October he's downloading 4 songs and gets the bill for $11.96. So those were my 2 points. And then last but not least, I need to write my equation. Remember, first step, find the slope. And then my slope ends up being 2.99, 299. And it depends on which point I choose to use as to which equation. You don't have to have both, one or the other. If you used this point, you'll have this equation. If you chose to use that point, you'll have that equation. And then regardless of which one you use, when you solve for y, that's what you get in slope-intercept form. And again, if the next question was, oh, okay, so what would he pay if he downloaded 7 songs? So if he downloads 7 songs, that's an X because it's the number of songs. And I would then plug in, y equals 2.99 times 7. And I got to get out my calculator because I don't know what that is. But 2.99 times 7 is 20.93. So that would tell me that month when he buys or downloaded 7 songs, his bill would be $20.93. Okay. One last problem. Oops, excuse me. So here you go. Farmer Josephine trying to grow a pumpkin. Define your variables. Think about which one's independent and dependent. Pause the video. Go through this whole process, and then we'll review it. Okay, so when I read this, I think about what's changing. After 1 month, her pumpkin weighs 2 pounds. And then after 3 months, her pumpkin weighs 9.2 pounds. So it sounds like my pumpkin's getting heavier, right? So the weight of my pumpkin is Y, and that's dependent upon how many months have gone by. So the number of months that pumpkin's growing is X. Now, again, your points have to be X comma Y. So when the pumpkin's 1 month old, it weighs 2 pounds, so 1 comma 2. And when it's 3 months old, it's 9.2 pounds, so 3 comma 9.2. Same thing as before. First step is to find my slope. My slope ends up being 3.6. And either one of these equations is 100% equally correct. It just depends on which point you pick to plug in. But no matter which point you use, no matter which one you get on the left or the right, when you solve for Y, you should still get the same thing. So if you didn't get this at the end when you solve for Y, go back and check your work. All right, that's all I have for you today. Thank you so much for watching. Have a great day.